lesson for today. We're going to start looking at prime factorization before looking at the next step, taking the square root of a number. Now, what this means is that prime numbers are what we want to end up with. And prime numbers are only two factors. That means they are divisible by itself and 1. So like numbers like 2, 3, 5, 7, 11, 13. Those are all numbers that cannot be divisible by any other number except for itself or number 1. So here in our example, we're going to factor apart 48. And what I'd like for you guys to understand about factorization is think of dividing. When you take a number, you want to split it up into smaller numbers that is divisible by. So in this situation, I take the number 48 and I divide it into 6 and 8 parts. Does that make sense, right? So 6 times 8 is 48. So I divide it and I separate them into two factors, 6 and 8. But I can take 6 and 8 and divide and factor it again to make it into 2 and 3 and 2 and 4. And then the last number that I can divide within the factor tree is 4, and I have 2 and 2. So do you notice that they circle the numbers here, right? They circled the prime numbers that I cannot go any smaller than that, right? Prime numbers are divisible by itself and 1. So what do I have? Hold on a second, guys. I'm going to do attendance here real quick. All right. So in this situation, let's take a look at an example. Let's say I want to factor apart 300. Can you guys see this pretty well? Make it a little bit bigger. Okay, I want to factor apart 300. So again, I'm going to take 300 and think of what can 300 be divisible by, right? To turn it into two factors. That's one thing I'm looking at. So I take 300 and I want to divide it into two numbers here. What two numbers can multiply together to give me 300? So you can use a calculator and figure it out. Can I divide 300 by 2? Can I divide 300 by 3, by 10, by 15, by 100? Okay, 150. So Ethan gave me 150. So 300 divided by 150 gives me what other number?
2.
Very good, 2. So that's my first split, right? Two numbers I split apart. I got 2 and 150. Now I'm going to circle my prime number. 2 is one of my prime numbers, so I'm circling that. Then I'm going to break this apart. 150. I want to divide that number into two numbers. What numbers do you think they could be?
75.
Okay, 75 and what else?
50.
50?
2.
2, thank you. So we're going to go with that.
Oh.
Yeah, there we go. So 75 and 2. So here's my other prime number. Here's another one. Now this factor tree is all attached to 300. So I'm just creating the tree and getting larger and larger down to the base. Now 75 can be broken up into two numbers. What two numbers are they?
25 and 5.
That's too big.
3.
3, thank you very much, 3. So here's my other prime number. Very good. Now I'm down to just 25. 25 can be broken up into what? What two numbers?
12.5 and 2.
Well, I can't have decimals. I want whole numbers.
5.
5 and 5 times what gives me 25?
5.
That's right. And these two numbers happen to be prime numbers as well. Exactly. So now we circle all these prime numbers. And so what we're going to do is we're going to rewrite 300 as a multiplication of these factors in red, encircled in red. So 2 times 2 times 3 times 5 times 5. So this is the main practice for today. How do we take a large number and break it up into prime factors? So prime factors, okay, are listed as multiplications numbers to each other. So 300 is equal to 2 times 2 times 3 times 5 times 5. That's it. So let's practice with 228. Just like we did before, we're going to break apart the original number into two numbers. What can 228 be divisible by?
114.
Okay, 114, and what's the other one?
2.
Correct, very good. So which one of these two numbers is the prime number?
2.
2, correct. Now we take the other number. Now 114, we're going to break it apart. Whoop, okay, someone wrote down 50. Okay, so Ethan wrote down 57. That's one number. Can someone tell me what's the other number that's multiplied to it to give me 114? All right, 2. Thank you, Ethan. So again, 2 is my prime number. Now 57. I want to break apart 57. Can I break it apart?
19 and 3.
That's very good. Thank you. 19 and 3. Can I go any further with 19, or is that a prime number?
Prime.
Prime. Very good. It's prime. I can't go any. Once I can't go any further, that's prime. So 3 and 19.
If you can't go further, you're done.
Pretty much, yeah. Well, you don't want to be dead, but you know, you just can't go any further. So 228 equals 2. All those numbers circled in red, we're going to show them as a multiplication process operation. And that's it. That is your prime factorization of this number. Okay. Now, with the other classes, especially for first period, I went a little bit further than prime factorization. I actually went on to the second page of this, which was actually square rooting the number. And I realized I went a little bit too far. We're going to see some more of it again, but I figured, you know what, I don't want to leave you guys out. So I'm going to show you guys a few things with this. Okay. So now that we have an understanding of prime factoring, just keep in mind, we are still showing them as being multiplied together to get the original number. All right, so I'm going to go ahead and clear it. And I'm going to move down to this page. All right, so parts of a radical. There's some blanks here, okay? What's in the star right here? This number is your root number. Okay? Roots are basically another word for factors. So for example, if I'm taking the second root of 14, I'm taking the square root of 14. Okay? Because for 16, I'm sorry. So for example, what's the square root of 16? I plug 16 into the calculator and I press that square root symbol and it gives me 4. If I put in 100, it gives me 10. Okay? So this is an operation. So this is my root number. If the root is not written, it is automatically a square root. Okay, so a square root meaning this. We just write 2 right there. But this is synonymous with just plain old radical. Okay, so that's what that means. So I'll give you guys a moment here. The number inside, okay, is the number that I'm going to take the square root of. So I'm going to go ahead and clear. Again, I'm recording this so everybody understands. So number 1, find the prime factorization of the number inside the radical. Okay, so that basically is what we did in page 1, right? We broke it apart into its prime factors. Number 2, we're going to determine the index of the radical. So the index of the radical means the root number. In this class for the rest of the year, We will focus only on the square root to have a firm understanding, okay? Next year, when you go to Algebra 2, you guys go on to bigger roots, like the third root, the fourth root, the fifth root, okay? You guys get a little bit more complicated. We're just going to start with the basic knowledge of the square root. And then we're going to move each group of numbers or variables from inside the radical to the outside, and then simplify the expression. So how are we doing that? Let's take a look at this. First thing we're going to do is we're going to only prime factorize the number inside the square root. And then the second thing I want to do is show you guys how to square root the number without having to end up with using a calculator. The only time you're going to use a calculator is just to double check, like, okay, is this divisible by 4, by 5, or by 7, and so forth. So let's take 252 and think to ourselves here, what can 252 be broken up as? Can it be divisible by 2, by 4, by 10, 12, you know, anything? This is where the calculator comes in. You want to try to simply understand. All right, so Ethan's telling me 126. Can someone else tell me what other number I multiply to 126 to get 252?
2.
Thank you, 2. So remember, anytime I end up with a prime factor, immediately circle it so I know that this is what I'm going to represent what the number is at the end, multiply to another number. Then I go back to the other composite number. Composite numbers are numbers, again, made up of prime numbers.
63 and 2.
Very good, 63 and 2. Okay, so we're getting smaller. And as we get smaller, it becomes easier. So I have 2 times 2 times 63, but I can break up 63 as what?
$21.
21 and 3. Okay, very good. Let's go 21 and 3. So, whoops, let me do a different color. So I'm going to write it as 21, as 3 times 21. So we notice we have another prime factor, right? 3.
And then if you go down more, it's 7 and 3.
Correct. And can we go any further than that, guys?
Stop.
Right, we stop right there. Very good. So I'm going to circle these prime factors. These are the numbers that I'm going to show that multiply together to give me 252. So 252, the square root of it is equal to the square root of, let me do this in red, 2 times 2 times 3 times 3 times, now I'm going to go ahead and do a different color for the 7. I'm going to write this guy in blue. And the reason why I'm writing him in blue is because, do you notice, bless you, do you notice, you were sneezing? Sorry. Oh, sorry. So do you notice that, do you notice the numbers in red, they have a pair, right? 2, 2, 3, and 3. Everyone should be able to see that. The 7 is the only number that's by itself. So I wrote the 7 in a different color to show, like, hey, it's the Lone Ranger. It's by itself. But the other guys have the exact same pair. They're exact pairs. So this is one extra step. That's actually what I didn't have to do today, but since I did with other classes, I want to give you guys that chance to be introduced to that. What this helps me to do, it helps me to see that if I have more than a pair of the same numbers being multiplied, I can multiply those numbers together to get one big factor number. So I will have the square root of 2 times 2 is 4, times 3 is 12, times 3 is 36. Then times my blue Lone Ranger right here. Okay? So what happened is this got combined to this. Okay, now why am I doing that? I thought we were prime factorizing. You're right. This is definitely a good way to end up with right now from what we're doing for lesson today. But what happened was, again, I was doing the square root of the number and I kind of went a little bit too far. So I'm actually introducing a little bit more information than what we needed to just for today.
So the answer is 36 times 7?
Close, not just yet. We can go further. We can actually take the square root of this number, but we can only take the square root of one of those numbers. And the only number we can square root is actually 36. So I'm going to show you how to express that. Now, anytime two numbers or three or four numbers or whatever are multiplied underneath a radical, I can separate them. So that means I can write a radical for each of the numbers. So I can write a radical over 36, then multiply it to a radical, to the radical with 7 inside. So basically what I did was I'm writing explicitly a radical for each number, but it only works if I'm multiplying them together, okay? So that's why we're doing the prime factorization. You see that they're all being multiplied, and then I can take the numbers that are being repeated again, put them back together, and I actually create one giant factor that can be square rooted perfectly. So if I put this in the calculator right here, okay, if I type it in right now, if I do 36 and then I square root that number, what do I get? What's the square root of 36? Say it again?
6.
That's right, 6. So I'm left, this becomes 6, right? When I operate it, it becomes 6. But the other guy, I just leave it alone like this. I write it right after it. So my actual answer is 6 times the square root of 7. And that's without having to calculate it on the calculator, because the calculator will give me a decimal for this. But this is the actual correct representation of it. So what I did was we broke it apart, right? And we found out what were repeating terms. See these two repeated, right? 2 and 2. These two repeated, 3 and 3,
I
right?
know we did, but is that the answer?
That's the answer right there in the box. 6 square root of 7. That's your actual answer. So when we're taking the square root of it, that's what we want to do. The prime factorization helps us to expand and see how many numbers are repeated over and over again. And if I see a number repeated more than twice, more than once, I should say more than once, I multiply them all out, and I actually get a number that can actually be square rooted perfectly. So the Lone Ranger just kind of gets written down. Like, see how I noticed nothing happened with 7, right? I just wrote it all the way down with a square root over it, and that was it. So with 405, I'm going to do the exact same thing. And what you're going to see is that 405 can be split up as 81 times 5. Put that in the calculator and you can double check it. 81 times 5 gives me 405. Now, 81, so 5 is one of my prime factors, but 81 can be split up. Into 9 times 9, and then 9 can be split up into 3 times 3. So how many times, guys, do you see 3 repeated?
4.
4. Correct. 4 times, right? So guess what? So since that is repeated more than once, since that's already repeated more than once, if I multiply them, right, because they're all being multiplied together, correct? I actually get this.
You get 81.
You get 81 times the square root of 5. So this whole thing is actually saying the square root of 405. But because I broke it down to the factors, the prime factors, and I showed I repeat it more than once, if I multiply them all back together, I got one giant factor that can be square rooted. So the answer is going to be what? The square root of 81 is
9.
9. times, can I do anything with the square root of 5? No. So you leave it alone, and that's your answer. And that's it. You guys are my good class, man. You guys are awesome. This is what I'm talking about. So do you see the factorization helps us to see, okay, this repeats, right? This repeats, so I know that I can multiply these guys together and square root them. Okay? So, and the only way that they can be square rooted is if I have an even number of squares. So like 2 times 2, 3 times 3, or 3 times 3 times 3 times 3. Yes?
But the other one when you did that will be the 3 times 3 times, or 2 times 3 times 3.
This one here?
But did we do that on this one?
Say it again, which one was it?
Because on that one we did 2 times 2 times 3 times 3.
Right.
Why didn't we do it on this one?
On this one? Because we only had 3s.
So if you have all the same numbers, you don't do that?
Right. So if I have the same number, I multiply them together to see, do I get a big enough number that can be square rooted? And that's the thing. I'm looking for, I break apart, the factorization helps me to break it apart and see, okay, I got small numbers, and small numbers are easy to multiply to each other. It takes a while, but you can see it. And I look at the largest number that I can actually create out of those factors to square root it. So this becomes my actual answer. So the main purpose of today, guys, the main lesson is really looking at this. How do we factor apart to identify prime factors? That's the main lesson. What I did today was go over actually several more lessons all in one, and you guys are getting it. I mean, I know it's a little, we'll give some time. I'm not going to test you right away. Tomorrow we'll have a small lesson on it, you know, like first with prime factoring, and then moving on to, okay, can we square root which part? So I'm going to go ahead, I'm going to stop recording here.